Good evening, class. In our yesterday's session, in our last session, we have completed the concept of recursion. As you can see, this is the complete syllabus of Unit 4, and in that, we have completed functions, concept of functions, concept of recursion in our previous sessions. So, concept of functions we have covered, concept of recursion we have covered, and only concepts which are left in your fourth unit are the standard library functions. We need to discuss some C standard library functions. This we do in today's session, and also the dynamic memory allocation. So whatever I have highlighted using the red color, these topics we are going to discuss in today's session. Okay. So quickly, I'll take you to the standard library functions concept. So these standard library functions all are predefined, and they are available in header files. We have header files, and these functions they are available in header files. We no need to use any function definitions. Okay, we are not going to write any function definitions for these standard library functions. So C is having a rich collection of these type of standard library functions, but we are not going to discuss all, because discussing all of the functions it will take more time. So we have picked very few functions, few predefined functions, and we are going to discuss how they will work. Okay, as per your prescribed textbook, whatever functions they are asking us to discuss, that only we will discuss in today's session. Okay, so around 6 to 8 functions we have. We need to discuss only those functions, and they are very easy to understand because we are good in mathematics. We know how some mathematical operations will be performed. So these functions they resembles those operations. Okay, the way how we perform these operations in mathematics, these functions will give the same result to us. Okay, and to use these functions we need to include library files specific to the functions. Okay, basically these library files or these header files they will have the declarations related to those functions. So instead of writing the declarations in our program, what we do, we simply include, using the hash include preprocessor directive, we simply include these header files into our program. Okay, instead of adding each declaration separately, a simple statement with the header file can be included on the top of the program. So as a first statement, okay, as the first statement, we basically include these header files which are going to have the definitions for all our predefined functions. We'll keep these header files at the top of the program. Okay, hope you understood, ma. So how to make these standard library functions functionable in our program, in the sense by including their respective header files. So and where we keep these header files at the beginning of the program itself, as the starting of the program itself. Okay, hope you understood. So as we said, we discuss only the math functions. We are not going to discuss anything apart. We will discuss math functions, and it doesn't mean that we have only math functions, math related functions in C language. We can perform any type of task. There are some thousands of libraries available in C language, specific to the domain or specific to the type of operations, type of calculations we perform, specific to the type of tasks which we calculate. We have thousands of header files, and all that to discuss it is not possible. So we are discussing only one or two library files. That is, one is math.h and the other one is standard lib.h. Okay. Basically, we discuss mathematical calculations. Okay. The functions which are available or which are possible for mathematical calculations, that only we will discuss. And most of these mathematical calculations functions, as they are available either in math.h or in stdlib.h. So we need to discuss these two header files. Okay. And these two header files also we are not going to discuss completely. Only very few functions from these header files we are going to discuss. Okay. So in that, the first type of function which we discuss is the absolute value function. So we know that in mathematics, absolute value means the positive value irrespective to the value supplied. These absolute value functions will always give the positive equivalent, positive value of that given value. Okay. So here you see that definition. What do you mean by an absolute value? An absolute value is a positive value of the value regardless of its sign. So whatever sign the value is having, if you apply this absolute value thing, you will always get a positive value. ఓకే. నెగటివ్ వాల్యూ పాస్ చేసినా మనకు పాజిటివ్ వాల్యూనే వస్తుంది, పాజిటివ్ వాల్యూ పాస్ చేసినా మనకు పాజిటివ్ వాల్యూనే వస్తుంది, ఇర్రెస్పెక్టివ్ టు ఇట్స్ సైన్. Okay, irrespective to the sign of the number, we always get a positive value only. Okay. So we have around three integer functions to calculate the absolute value and three floating point functions to calculate the absolute value. Three integer and three floating point library functions we have in order to calculate the absolute value. Three integer in the sense for whole numbers. Okay, without fractional parts they deal with, and floating point in the sense with fractional part they deal with. Okay, integers for regular integer, for long integer, and for long integer. Three different types of functions we have under integers category. As you can see here, the integer functions are abs function, absolute function. This is for normal int type. Normal int type. As you can see here, I have written for absolute function. Okay, the parameter is nothing but input. The input, the parameter must be an int, and return value must be an int only. So what this function will do, here you can see the normal absolute function. What it is doing, it is taking a simple integer or normal integer value as parameter, as input, and returning a normal integer value only as output. Here you can see that one. So whatever value you supply here, positive, negative, what you will get, irrespective to of its sign, you will always get a positive value only. Irrespective of its sign, you always get a positive value only. That is what this absolute function will do. Then L absolute or long absolute function. Okay, L absolute or long absolute function. This is associated with long integer. Okay, long integer. So the L absolute, it will take the parameter long integer, parameter input, and return value long integer only. Output will be long integer only. So return input, you are giving positive, negative, long integer, you will always get the return value as positive long integer only. So that is what here you can see. L absolute will take the long integer as parameter, as input, and return long integer only. Okay, taking either positive or negative input and returning always positive output. Okay, do understand this thing. Okay, here also the last thing, we have LL absolute, that is nothing but long absolute, and LL absolute must be a yeah, the parameter must be a long integer. Here it will take no long. Here one long is missing actually. So the parameter must be long int, no long int only. Okay. The syntax you can check, general syntax you can check. Parameter will be long int only, not long. Parameter will be long int only, and return value long it will return. So here, this in place of this int, you have to put long. Okay, there is a mistake in this one. In place of, because we said now normal integer only, we have to call it like an integer. If it is long integer, keeping only long, and if it is long integer, keeping long is enough. Okay, whenever we specify as a parameter or as a return value, but when we declare it, you must have to put long int likewise. So it will take the parameter of type long, return value long only. Okay, so don't get confused over here. Parameter will be long and return value will be long only. Okay, like this you remember. Okay, just based on the size, we have three different sets. Okay, three different possibilities for our absolute function. Okay, this is in case of integers. Normal integer, use only ABS. Long integer, use LABS. Long integer, use LLABS. Okay, likewise we have three different types of functions for calculating the absolute value for a integer. So absolute value in the sense, whether you are giving negative value, positive value, you will always get a positive value only as output. Then for floating point numbers, for fractionals, for floating point numbers, again here also we have three different types of functions for calculating the absolute value of floating point numbers. Okay, the first one, as you can see, f absolute, it is associated with double. Okay, f absolute, it is associated with double. It will take input of a double value and returns a double value only. Input may be positive, may be negative, but output always positive. Okay, then f, this is for float value, floating point number. Okay, here you can see the detailing. For f absolute, the parameter is a double and return value also double. Okay, for normal f absolute. For f abs f, this f indicates, the second f indicates floating. Okay, floating point absolute for float. Likewise you can remember, the parameter is float and return value is also float. Okay, then floating point absolute for long double. Here when you have L, this L indicates long double. Floating point absolute for long double, it takes the parameter long double and returns value as long double only, and returns long double only. Okay, hope you understood. So always for absolute functions, the input will be either positive or negative, but output will be always positive. Just it will invert the sign. If you are giving, we cannot say invert, just it will give the positive sign always. If it is positive, it will remain positive. If it is negative, it will be converted to positive. Likewise, it deals with sign only, not the number magnitude. Okay, so f absolute, as you can see, it is taking double parameter, returning double return value. Then f absolute f, it is taking float value as input and returning float value as output. Then f absolute L, it is taking long double as parameter and returning long double value. This is parameter, this is return value. Okay, hopefully you understood. So this is how, and one small demonstration will be there for this program, for this topic, a program demonstration. So this is the program, as you can see. Yeah, in order to use this f absolute, I'm using only one f absolute f. With respect to float, I'm using the absolute function. You can try all 6 functions, the 3 integral, 3 floating point we have. So you can try all 3. What are they? Once again, I will write here. First one is ABS. It deals with only normal regular integer, takes integer, returns integer. Then ABSLR, ABSL, I guess. Sorry, LABS. LABS, what it will do? It will take a long integer and return a long integer. Then we have LLABS, absolute. Long absolute, it will take a long integer and returns a long integer. Then floating point, we have FABS, floating point ABS. This deals with double. It will take double as input and returns double as output. Then FABS F. This takes the float as input and returns the float value as output. Then FABS L we have long double. Okay, it will take the long double as input and long double as output. These 6 functions you have to practice. You can practice, but here we are practicing only this one. Okay, FABS F, it will take a float value as input and it will return a float value. As you can see, float value is equals to, I have taken the negative value in it, minus 2.64674. A negative value I have taken into this val variable, and that val variable I am passing as an parameter to this one, and whatever this f absolute f function is returning, that I am storing into result. Okay, that I am storing into result variable. So here obviously what this f absolute f will do, ma, it will convert the sign here, plus minus sign is there now, it will change that sign to plus, and we will get a positive value into result. Simply print that result over here. Value, after performing absolute on that value, we are printing the result. So here you can see absolute value of minus 2.674 is plus 2.674. Just it is converted the sign from negative to positive. If you give positive, it will remain positive. It will not change in that case. So just you need to notice this one. As you can see here, the actual number magnitude, the actual number is not changed over here. It is as it is, but just the sign is changed from negative to positive. Okay, hope you understood this absolute functions. Okay, so then we have our second type of functions, second function, that is ceiling function. Okay, ceiling function, what it will do is, it will always do the round figure kind of thing for the given number. Okay, so it will always take what we call a precision value, and it will try to make it as an integer. Okay, how it will make, we will discuss, but you just remember, it will always take a fractioned value, and it will convert that value as an integer. Okay, so ceiling function now, what value it will select as an integer, what value it will select in the sense, always on the number series. We know, ma, the number series will be like this, 0 will be in the center, and on the right hand side we'll have all positives, 1, 2 and so on up to plus infinity, and on the left hand side we will have all negative numbers like -1, -2 and so on till minus infinity. Likewise we have, if you treat this as your number series, okay, number line, on the number line, your ceiling function, whatever value you supply now, your ceiling function always look for the nearest integer value in the right hand direction. Always look for the nearest integer value in the right hand direction. So if I give, here you can see, if I give minus 1.9, so this minus 1.9, where it will come? Somewhere here, as you can see, this is the point where minus 1.9 will come. So when you apply the ceil function on minus 1.9, what it will do? It will look for the nearest integer value in the right hand side. Okay, of course, left hand side immediate value 2 we have, 2 as an integer we have, negative integer we have, but it will not check, I mean it will not take the 2, rather what it will do, it will always look for the nearest possible integer value in the right hand direction. So if you move in the right hand direction, what is the nearest possible integer value in the sense, for this minus 1.9, minus 1 is the nearest possible integer value. So it is taking minus 1 as output. Okay, this we have supplied and this it is taking. So in the positive side, how it will be? So we are taking plus 1.1. So where that plus 1.1 will go? At this point, 1.1, it will stand somewhere here, 1.1. So as I said now, when you are giving 1.1, it will always look, 1.1 is a fractioned number. We have fractional part, 0.1 fractional part we have. So it has it has to do the round for that value. It has to take the what we call integer equivalent of that value. So what it will do, it will move in the right hand direction on the number line, and it will select the nearest possible integer value in the right hand direction, and that is 2 in this case. So it will assign 2. It will return 2. Ceil of plus 1.1 is 2. Here ceil of minus 1.9 is 1, as you can see. Okay. This is the explanation. Whenever you are calculating ceil value, this will be the explanation. Okay. So now we will see the declarations or the syntax for these functions. Ceil, it will always take a fractioned number, floating point number as input, because it has to give the input in terms of fractions, isn't it? Okay, decimal points lo ivvali input kabatti always it will take the input as the fractioned floating point number. So regular normal ceil will take always double as input and return double as output. Double input తీసుకుంటుంది, double output return చేస్తుంది. Okay, and ceil f will take float input returns float output, ceil f. And then we have ceil l. Ceil l will take long double input and returns long double output. Okay, so once again, ceil, regular ceil will take double number as an input and returns double as an output. Then we have ceil float. Ceil float always take float as an input and returns a float as an output, float value as an output. Then ceil L we have, ceil L will always take a long double input and returns a long double output. This is how this ceil function will work. Okay, ceil function already I demonstrated. Ceil means always whatever value you supply now to this ceil function. Okay, always it looks for the equivalent integer value in the right hand direction on the number line. Right hand direction లో nearest possible integer value ఏదైతే ఉంటుందో ఆ value ని return చేస్తుంది. So when you are giving minus 1.9 as a parameter to this ceil, what it is returning? It is returning minus 1.0, as you can see here. Minus 1.9 you are giving and it is returning minus 1.0. Then if you give ceil of 1.1, it is returning ceil of 2.0. Okay, 2.0. So this I have demonstrated why it is returning 1.0, why it is returning 2 here. We have discussed in our previous slide only. Okay, so this is the program for demonstrating the ceil function. So ceil with two values I have demonstrated. One is positive value and one is negative value. So ceil of 2.674 we are calculating and ceil of minus 2.674 we are calculating. Now these two we need to identify and we are storing in result and we are printing it. So ceil of 2.674 where it will be, it is in the positive direction, so I will draw the number line only in positive direction. So we know that 0 will come here, 1 will come here, 2 will come here, 3 will come here. Okay, so where this 2.674, 2 half and this may be here, 2.674 maybe it will come here, 674. So if you apply the ceil on this value, if you apply the ceil on this value, in what direction it will move? In the right hand direction it will move. On the number series it will move on the right hand direction, and when it is moving on the right hand direction, the nearest possible integer value is 3. So ceil of 2.674 will be 3, that you can see here. Ceiling value of 2.674 is 3, it is returning, because we have calculated ceil of that value. This we are storing into value variable and that we are passing as a parameter here, and we are calculating the ceiling value. Because it is a float, we are using ceil f, and whatever result we are getting from this one, whatever return value we are getting from this one, that we are storing into this result variable. And when you are printing that result variable over here, we see 3.60 we got. Okay, so this is the explanation for that one. And next is negative, minus 2.674. Where it will stand? I have to go in the negative direction, so this I will consider it as 0. This is minus 1, this is minus 2, and this is minus 3. And minus 2.674, where it will stand? This is half and maybe somewhere here, minus 2.674. And as we have to move in the direction of right hand direction, so then I will move in this direction. And what is the nearest integer? minus 2 is the nearest integer. So when I'm applying sealing function, when I'm applying seal function on this minus 2.67, I'm storing it into val, and that val I'm passing as parameter here. And because it is a float, I'm using seal f. So whatever return value we are getting, that we are storing into result. And we know that return value has to be minus 2. Here you can see that one. When we are applying seal on the minus 2.674, we are getting minus 2.0. So this is how the seal function will work. Hope you understood. Okay, first we discussed absolute values, which we convert just a given number into a positive number. Irrespective to the sign, it will always give you the positive sign to the number. Then sealing, always it will calculate, it will identify the nearest possible integer on the number line for the given fractioned value in the right hand direction. Okay, then we have the floor function. It is opposite to seal function. As seal function will identify the nearest possible value in the right hand direction, the floor function will identify the nearest possible integer value in the left hand direction. Opposite of seal. So మనం ఈ కేసులో మనం ఏ డైరెక్షన్ లో మూవ్ అవ్వాలి? We always need to move in the left hand direction, as you can see here. Left hand direction. Previously it was here, right hand direction, as you can see here, right hand direction. But now it is, we need to move on the number line, we need to move in the left hand direction, and we need to search, we need to look for the nearest possible integer in the left hand direction. So as you can see, when we are calculating the floor of minus 1.1 and minus 1.1, as we know, this is 0, this is minus 1, and 1.1 will come somewhere here. Minus 1.1 will come somewhere here. And to get the floor value of this minus 1.1, we need to move in the left hand direction. So we are moving in the left hand direction, and the nearest possible value was 2.0, minus 2.0. So this minus 2.0 will be returned. From this floor function, minus 2.0 will be returned. Same here, when you are trying to identify the floor value of plus 1.9, plus 1.9 plus this is 0, this is 1, this is 1.9, maybe somewhere here. So always we need to move in the left hand direction. So we are moving in the left hand direction, and the nearest possible integer value in the direction of left hand, we got 1. So that 1 will be returned from this floor of plus 1.9. We got 1.0. Okay, even if you demonstrate, if you execute these programs, you will get the same thing. Okay, so the program demonstration, yeah, the syntaxes again. Normal floor will take double, floor F will take float, and floor L will take long double. Normal floor will take double and return double. Okay, floor F will take float input, float output, parameter float, return value float. Then floor L will take long double input and returns long double output. Okay, so this is how this floor F, floor L will work. Okay, so here what we are doing, we are calculating the floor value of a negative number, that is minus 1.1. So as we need to move in the left hand direction, so for minus 1.1 in the left hand direction, we will have minus 2 as the nearest integer value. And for 1.9, okay, 1.9 positive side, so floor of 1.9, we need to move in the left hand direction. So we will get the nearest possible integer value in the left hand direction, that is 1. Okay, we need to move in this direction. So in this direction 1 will be there, so we will get 1. Okay, so even if you execute the program, just what I have done, I have created a variable val, and in that I have stored 2.674. so I will draw the positive side for your understanding. 0, 1, and this is 2, and somewhere here this is 3, and 2.674 in the sense, if this is half, somewhere here your 2.674. okay, and if you apply the floor on this, what you will get, we need to move in the left hand direction, and the nearest possible value in the left hand direction is 2, so you will get 2. Okay, so this is what here you can see. After calculating the floor, because it is a floor, we are using floor F. Okay, floor F of the given value we are calculating, and the value we know, 2.674 only. Result, the return value will be stored in result, and if you check, okay, this is value, this is result. What is value? 2.674, and what is the result? We will get 2. Here you can see that one, 2.674. When we are calculating the floor f of this 2.674, we are getting 2. Okay, hopefully it is clear. Then I'm storing minus 2.674 in this val attribute, and floor f, okay, because it is floor f of val. When I'm calculating, what I'm getting, the result, yeah, always we need to move in the left hand direction, and if this is your 0, this is your minus 1, this is your minus 2, this is your minus 3. Okay, what we have to move? Minus 2.674 we need to identify. This is 2, this is 0.5, here somewhere here it will be minus 2.674, and as always we need to move in the left hand direction. So if you move in the left hand direction from here, the nearest possible value is, possible integer value is minus 3. So this minus 3 we will get as input. So minus 2.674, when we are applying the floor f on this one, we are getting minus 3, as you can see here. Okay, hopefully it is clear, ma. And why we are not having integral functions, ma? Because they will take only floating point numbers, ma. They will not take integrals. Your ceil functions, your floor functions, they will take floating point numbers. Integer, already it is a whole number, already it is an integer, so there is no point of rounding that value, isn't it? Only if the value is a floating point value, we try to round up that value. If it is already an integer, there is no point of rounding up that value. Okay, hope you understood. That's the reason we don't have any integer equivalent for these functions. Okay, so here next is the truncate function. So this truncate function, neither it will go in the left hand direction nor it will go in the right hand direction. It will go always in the zeros direction. Okay, wherever we have 0 in the number line, on the number line, we always move towards the 0 and we identify the nearest possible integer value in the direction of 0. Okay, that is what here you can see that one. This function always return the integral value in the direction of 0 here. This function, this truncate function name is truncate. The truncate function, it always returns the integral value in the direction of 0. Okay, in the direction of 0 it will return the integral value. Okay, so for positive numbers, because it is returning in the direction of 0 now, so for positive numbers it is same like floor function, and for negative numbers it is same like ceiling functions. Because for positive numbers we need to move in the direction of floor function, we need to in the direction of right hand, so floor function. Sorry, in the direction of left hand, so floor function. For negative numbers we have to move in the direction of right hand, so ceiling function. So this truncate function, it is equivalent to ceiling for negative numbers, and it is equivalent to floor for positive numbers. Hope you understood. So then always you remember we will move in the direction of 0. Okay, and the general syntax, if you see for this truncate function, again with respect to double, with respect to float, with respect to long double, we have 3 different syntaxes. Trunc, the regular trunc function deals with double. It takes input as double and returns value as double. Okay, then trunc f, it takes input as float and returns a float value as output. Then trunc L, it takes input of long double, okay, and returns the value as long double only, return value as long double only. So trunc, trunc F, trunc L. Okay, now what we have to do, ma, always we need to move in the zeros direction, not in left or not in right, always we need to move in zeros direction. So when you are calculating the trunc of minus 1.1, trunc of minus 1.1, if this is a negative number, so what I'll do is I'll take the number line. This is my 0, this is my minus 1, this is my minus 2. Okay, and where that 1.1 will go, yes, this is minus 1, and this may be this thing is minus 1.1, and if you apply trunc on that one, if you apply trunk on that one, what will happen? We need to move in which direction? We need to move in zero's direction. As we have 0 here, we need to move in this direction towards 0. So towards 0 when we are moving, which is the nearest possible integer? -1 is the nearest possible integer. So that's the reason we are getting -1 as output here. Okay. Then take positive direction, positive side. Input is 1.9. So number line, take this as 0, this as 1, this as 2, then 1.9. Where this 1.9 will go? Here. Okay. 1.9. This is your 1.9. Okay. So then what we have to do? To identify the roundup value using this trunk, we need to move in the zeros direction. As I have 0 in this direction, left hand direction, I need to move from here, and when I'm moving like that, which is my nearest possible integer which I encounter? 1 is the nearest possible integer which I encounter. So 1 will be the result. Hope you understood. So here we are moving in this direction, and here we are moving in this direction. Okay, when we are moving like this, -1 we encounter as the nearest integer, and when we are moving like this, we encountered 1 as the nearest integer. Hopefully you understood. So these are the syntaxes for the functions and examples for the functions. Now the program demonstration for the 2.674, given value 2.674, what will trunk f, because I'm storing this 2.674 into a float variable, I need to use the trunk f function. Okay, trunk f function respective to float. Okay, the value which I initialized, I'm passing as a parameter over here. So what this function will do? This function will identify the nearest possible integer in the direction of 0. So for 2.674, positive, this is 0, this is 1, this is 2, this is 3. So where this 2.674? Somewhere here, but we need to move in the direction of 0, and when I'm moving in the direction of 0, the nearest possible integer is 2. So here when I'm passing value 2.674 for trunk f, what I will get? I will get 2.60. Okay, you can see here 2.674 I'm supplying, and I'm getting 2.60 in the direction of 0. Okay, next is I'm giving a negative value. I'm storing into a value variable, and that value variable I'm passing like a parameter here, and the returned value I'm storing into result. So just quickly, for -2.674, if this is my number line 0, this will be -1, this will be -2, and this will be -3. So now to -2.674, where it will go? This is half between 2 and 3, this is half, and 2.674, maybe it will stand here. So this is -2.674. Okay, -2.674 over here. So what I have to do? I need to move in the direction of 0. Okay, and when I'm moving in the direction of 0, the first integer which I encounter is -2. Negative integer -2. So the result will be -2. So -2.674 when I'm supplying to this trunk f, what I'm getting? -2.0 I'm getting, as you can see here. Okay, hopefully these two they are clear for you. How we use the absolute function, ceiling function, floor function, and now the trunk function. Okay, so that's just the directions you need to remember. In which direction we have to move, just the directions you need to remember, so as you can easily calculate the value which you will get. Okay, so lastly, the round value, round function. So it is the actual meaning in our real time, whatever we said now, whatever we say real in our real usage. Okay, in our day-to-day life, the way how we round up the value, this function exactly works similar to that one. Okay, so it will always look for the nearest, neither in the direction of 0 nor in the direction of left hand, right hand. It will always look for the nearest possible integer value, nearest possible integer. So what does it mean? Say suppose I'll take the number line. Okay, say suppose I have 0 here, I have 1 here, I have 2 here. So if okay, I will try to explain by taking the different examples between 1 and 2. So if I take 1.1, okay, if I take 1.1 as value, so which one will be the nearest integer? If my 1.1, where it will go? it will go here, somewhere here, 1.1. So which one will be the nearest value? Okay, 2 or 1? 1 will be the nearest. So it will round up this value to 1. 1.1 will be round up to 1. Okay, take another example. Say suppose 1.9 we have. 1.9. Where it will go? So 1.9, we know that here it will go. Somewhere here, this is 1.9. So which one will be the nearest for 1.1? 1 or 2? 2 is the nearest. So it will be 2. 1.9 round up value will be, round function value will be 2. 1.1 round function value will be 1. So it will simply check the exact equivalent, half it will check. Okay. If more than half means it will round up here. If less than half means round up here. Even 1.5 it will go to 2. We will check that one by demonstrating where it will go. So round function, what it will do, it will simply always look for the nearest integer value. Okay. So it will, yeah, again here we have three different types of round functions. Normal round deals with only double types. Okay, takes the double input and returns the double output. Round F takes the float input, float parameter, and returns the float output. Okay, float return value. Then round L will takes the long double input and returns the long double output. So round of minus 1.1, as usual, it will be 1 will be, minus 1 will be the nearest equivalent, and then round off 1.9, yeah, we know that 2 will be the nearest equivalent. Okay, even if you give 1.5, I guess it is equivalent to 2 only, but we will check it, how it will behave, we will check it by demonstrating. So here you can see the demonstration for round F. Float values we are passing, and we are calculating the round value near to the supplied value. Okay, so 2.674, we know that this is equivalent to 3. Okay, this is equivalent to 3, and minus 2.674, again it is equivalent to minus 3. Okay, minus 3, because when you put these two values on the number line, what will happen, ma? See here, this is positive value, so 0, 1, 2. Okay, this is 1, this is 2, and this is 3. Okay, so where this 2.674 will go, it is more than the half. Between 2 and 3, it is more than the half. It will come somewhere here. So which integer will be near to this 2.674? 2 or 3? 3 will be near. So equivalent is 3. Same way, when you put minus 2.674 on the number line, this is 0, this is minus 1, this is minus 2, and this is minus 3. So where that minus 2.674, this is minus 2, minus 2.5, 2.674, it will come somewhere here, minus 2.674. So as usual, as it is more than the half in the negative direction, it is more than the half. So obviously this will be equate to minus 3 only, minus 2.674. As you can see here, minus 2.674, we got minus 3, and that single thing I have to demonstrate. So let me just open the Dave CPP. Yeah, I'll open the program empty file, and now I'm typing my code. Okay, int main of void. Yes, we need to include math.h. math.h, and come down here and declare, because I'm going to use float only. Float of value is equals to, take 1.5. Okay, because we need to check where it will go, whether it will go towards 2 or whether it will go towards 1. Okay, so then result, float of result we will take, and we'll store result equals to what is that, round f. Okay, round f is my function, round f of val. Okay, now printf. Okay, round value of a percentile f is percentile f. Okay, comma, first percentile f will be the value, second percentile f will be the result. That's it. Okay, now return 0, save it. Okay, demo library functions we are doing, demo library.c. Okay, it got saved. Compile, run it. Yeah, as you can see, I told you now it will go to the 2 only. 1.5, it will go to the 2 only. Okay, so something like this. Hopefully you understood the concept of round function, which is used to make the roundup of given uh, a fractional value. Okay, a floating point value. Okay, so hopefully you understood all different functions. We started with absolute, then ceiling, then floor, then truncate, then round. Okay, now two more functions we have. In that, the first one is power function. So calculating the power. Okay, x to the power y. Here we are supplying two values now. Say the first supplied value is x and second supplied value is y. So what this power function will do, it will simply calculate x power y. Okay, this is what the functionality. We know this x power y in mathematics. We know this. We used many times. So this is to get this particular thing in our programming. We have to use power function. Okay. So these power functions with respect to floating points, we have regular power, we have power float, we have power long double. Okay. Regular power will work with the double types where both parameters. Here, as you can see, it is taking two parameters and returning only one return value. Okay, two parameters x and y. To calculate x power y, x and y, like kind of thing, it will take two parameters. It will take and it will calculate x power y and it will return a single value, the resultant value. Okay, and this normal power will be used with double types, and the power f will be used with float types, and power lf will be used here. An extra f is given. Power lf will be used with long double types. Okay, as you can see here, power of 3 comma 4. Okay, power of 3 comma 4, yes, 3 to the power 4 it will identify, and we know that it is 81. Okay, that is how it is returning. So knowing this syntax, knowing one example, it is more than enough and we know how to write C programs. You can easily write that C program as well. Okay, so here another function, square root function, sqrt function, square root function to calculate the square root of a given value. Okay, square root of a given value, and we know that always whenever we calculate the square root of a given value, the supplied value should be non-negative. Okay, whatever value we supply now, it should be non-negative. What happens if we supply a negative value? We know that it will be an imaginary value. Okay, because under root negative, if we give, it will be an imaginary value. From your mathematics, you know it. Okay, it will be considered like an imaginary value, the value which is quite difficult to predict. What value it will be, it is quite difficult to predict. So always whenever you use the square root function, try to give a positive value as a parameter only. Don't give a negative value. If you give a negative value, your program may crash, your application may crash, you will get some unpredictable results. Okay, okay. So hopefully you can read the second statement. It is relevant to what I have explained just now. So an error occurs if the number is a negative number. Okay. So the square root function, again we have three variants. One to be used with double types, another one to be used with float types, and the last one to be used with long double types. Okay. So double type square root, just regular sqrt without any suffix prefix, sqrt. Then float square root, sqrtf. Okay, the one which is used with float type, sqrtf you have to take, and the long double type to be used, sqrtlf. Okay, just consider this f only in case of this power and square root functions. We got this f extra over here. You just keep this thing in mind. And we know that when we calculate the square root of 25, the result will be 5. This is the example. Hope you understood how we are calculating the power and square root. Okay, so a simple program demonstration we have given over here, calculating the power and the square root of different values. So I have taken two values, value 1 3, value 2 4, a floating point type. Okay, a float type, not floating point, a float type. And to store the result, I am taking two variables of type float only, result 1, result 2. So in the result 1, I will calculate the power of value 1, value 2. Okay, value 1, value 2. So here I am supplying 3, here I am supplying 4, and result we know that it is 81. Okay, as you can see here, we got 3 power 4. Percentile f power percentile f is percentile f, like that we are printing, and here we are passing value 1, value 2, value 3. So first percentile f will be replaced with value 1, second percentile f will be replaced with value 2, and the last percentile f will be replaced with result 1. So we know that first value 1 is 3, value 2 is 4. So 3 power 4 is 81, like that we are getting. Then whatever result we got now here, for that result we are trying to identify the square root, because the result one is a float type of variable. We need to use the sqrtf, square root float. Okay, and we are calculating the square root of result 1. What is result 1 here? We have 81, and we know that square root of 81 is 9. So here you can see square root of 81 is 9 we are getting, and with this statement, with this printf statement, we are printing this thing. Hopefully you understood So all the types of functions whatever we discussed so far, they are important ones So sometimes they will ask you to write about some of these standard library functions from any of the header file likewise. So you can explain this all functions started with absolute, then ceil, then floor, then trunk, then round, then power, then square root. All these functions you can explain. Okay, hopefully the concepts they are clear for you. Okay, and our next concept in this session, before we wind up your fourth unit, one more concept we need to discuss. Just bear with me like 20 minutes, because I have not taken yesterday any class. Just bear with me like 20 minutes before we wind up. Okay, so our next concept will be the memory allocation functions, or more popularly known as dynamic memory allocation functions. Okay, memory allocation functions anna, dynamic memory allocation functions anna, same thing. Okay, so before we know what is this dynamic memory allocation, or what are these dynamic memory allocation functions, we must know what do you mean by memory allocation. Okay, memory allocation ante em ledamma, whatever variables we are creating in our program. Okay, we create variables, we create arrays, we create pointers, we create structures, we create functions, isn't it? All these we have covered so far. Okay, so any type of programming construct you create in your program, definitely it will consume some memory. Okay, some memory, some kind of memory from your computer. So how the computer will allocate that memory to your programming constructs, we call that concept as memory allocation. Memory allocation is nothing but allocating the memory for our programming constructs, maybe variables, maybe arrays, maybe pointers, maybe structures, maybe functions. Simply we are allocating memory to them. So that process we call as memory allocation. So this memory allocation in C language, we have two different types. One is static memory allocation and the other one is dynamic memory allocation. So see, when we execute the program, there are two trans. Okay, there are two types of trances we will have, or we can say two types of phases we will have. One is during the compilation or before the compilation. One is after the compilation or during execution. Okay, during execution. One is before compilation or during compilation. One is during execution. Okay, whatever memory allocation we do at the time of compilation, we call it as static memory allocation. At the time of compilation, this memory will be allocated. and whatever type of memory allocation, whatever variables we have created so far, whatever type of memory we have allocated so far, comes under the static memory allocation category only. Okay, nothing so far we did dynamic memory allocation. Okay, nothing so far we did dynamic memory allocation. In today's session only we are going to learn more about this dynamic memory allocation, and it is an important concept. It is an LAQ question, long answer question. Dynamic memory allocation, it is a long answer question. Do understand and remember. Okay, so dynamic memory allocation in the sense, at the time of execution of the program, we have the flexibility of allocating the memory, releasing the memory, kind of thing. So such a thing we call it as dynamic memory allocation. Not from the program, but from the output screen, we allocate the memory, we deallocate the memory, we delete the allocated memory, or we reallocate whatever we have allocated. We can change also. Okay, we reallocate the memory. All that we do from the output screen at the time of execution of your program. So that's the reason we are calling it as dynamic. Static means simple during compilation. Dynamic means during execution. ఎక్కడైనా సరే ఇప్పటి నుంచి మీరు ఏ సబ్జెక్ట్ చదివినా, wherever you have this static and dynamic things na, static in the sense during program compilation. Okay, during program compilation, and dynamic in the sense during program execution. Do understand and remember. Okay, static ante during compilation, dynamic ante during execution. We know how we compile the program, how we execute the program, because there are different phases ma. Compilation phase untundi, execution phase kuda untundi. We clearly can see whenever you write a program in your IDE, we have one set of commands to be typed for compiling the program and one set of commands to be typed for executing the program, isn't it? We are selecting, we are going to the environment options, and there we are selecting the compile option for compiling our program, and then we are selecting run option for executing our program. So whatever memory we are allocating during compilation, we call it as static memory allocation, and whatever memory we allocate during the execution of the program, we call it as dynamic memory allocation. Okay, so here you can see memory usage. Yeah, whatever our program, when it is under execution, whatever memory it will take now, it is divided into program memory and data memory, because we need to store the data as well as we need to store the program code also for the execution. Okay, we said that whenever we write the high level language instructions, those high level language instructions will be converted into machine level language instructions, and those machine level language instructions only given to the computer before it starts doing its task, before it performs its task. So that machine language instructions, they have to be stored somewhere in your program memory. Okay, somewhere in your program. So where it will be stored in the sense, inside the program memory only it will be stored. And what is the data memory will have the variables, the other stuff, whatever you declare in your program, that will come under the data part. Okay, data part will have all the variables, arrays, pointers, whatever you create inside your memory, inside your program, all that will come under the data memory. And what comes under the program memory? The code which we are writing for the program. Okay, the converted code into machine language will be stored under program memory. Okay, here you can see program memory consists of memory used for main and all other functions called. Okay, whatever functions we are calling, even main also a function, right? So main, including main, and whatever other functions we are calling from main, all that they come under the program memory. Okay, all that they come under the, we have the conceptual diagram in our next slide. We have that diagram, there you will understand more clearly. So simply remember, program memory means whatever functions we are writing in our program, all those functions will be stored inside the program memory. Okay, and data memory consists of permanent definitions, any definitions we are giving, like preprocessor, using preprocessor directives, we will create permanent definitions. So those permanent definitions will go under data memory, and global and local variables, whatever we create, global and local data, that also come under the data memory only. Okay, and dynamic data, the data which we create from the run time, okay, from the execution screen, from the output screen. That data will also come under the data memory only. So program memory will consist of all the functions, and data memory consists of all the data. Okay, so we know that as long as our program is under execution, okay, as long as our program is under execution, what do you mean by program under execution, ma? That is nothing but the main function under execution. Okay, as long as your program under execution, main function should be in the memory all the time. If your main function is exiting from the memory, that means your program stopped the execution, your program is no more under execution. So the constraint to say that your program is under execution is your main function should be in memory all the time. Okay, so then only we call the program is under execution, and main function may call any number of functions from it, or those functions can be in the memory or can't be in the memory. ఆ functions active ఉండొచ్చు, active అంటే మెమరీలో ఉండటం, deactive in the sense మెమరీ నుంచి అవుట్ అయిపోవడం. బట్ ప్రోగ్రామ్ అండర్ ఎగ్జిక్యూషన్ అంటే మెయిన్ ఫంక్షన్ కంపల్సరీగా మెమరీలో ఉండాలమ్మా. జస్ట్ దట్ థింగ్ యూ కీప్ ఇన్ యువర్ మైండ్. Okay, so in a function, if a function is called more than once, what will happen? The copies of the function's local variables will be created. Inside a function we are going to have local variables. If you are calling that function more than once, simply it will create um, more number of copies of the local variables. Okay, and those variables will be kept on the stack memory. Okay, we have a special type of memory in the conceptual memory diagram. We call it as stack memory, and whatever variables, local variables we create, all they reside on stack memory only. ఓకే, స్టాక్ మెమరీలోనే మన లోకల్ వేరియబుల్స్ ఉంటాయమ్మా. ఇంతవరకు మనం ఏదైతే వేరియబుల్స్ క్రియేట్ చేశామో ఆల్ దోస్ వేరియబుల్స్ they come under the static type of memory allocation and they fall under the stack only. Stack లోనే ఉంటాయి ఆ వేరియబుల్స్ అన్ని, స్టాక్ లోనే స్టోర్ అవుతాయి. There is another type of memory called heap memory. Okay, in addition to the stack memory, a separate memory area known as heap. హీప్ అనే ఒక మెమరీ ఏరియా ఉంటుందమ్మా మన ప్రోగ్రామ్ కి అలోకేట్ అయిన మెమరీలో, అండ్ దిస్ మెమరీ ఈజ్ unused so far because we don't know how to utilize it, isn't it? Because we don't know how to utilize it, so whatever program we have written so far, this memory, this heap memory was unused. In all those programs, this heap memory was unused. So to use this heap memory, what we have to do, we need to write a program, we need to write program by allocating, by using memory allocation functions. Okay, this memory pool, whatever heap we have, this memory pool we have, to use this memory pool we have to use memory allocation functions. Okay, memory allocation functions use చేసి ఏదైతే మెమరీ మీరు మ్యానిపులేట్ చేస్తారో, ఏదైతే మెమరీని మీరు మేనేజ్ చేస్తారో, we call that memory as heap memory ma. Do understand and remember, it is not the regular type of memory which we used to use for our variables. It is a special type of memory but part of our program only, program assigned memory only, program allocated memory only. You can see here the complete conceptual view of the memory. Whatever memory our program is assigned with, it is going to have two types of memory. One is the program memory and the other one is data memory. Program memory untundi, data memory untundi. Okay, and in the program memory what we will have, we will have all the functions, main and other called functions. Other called functions may be user defined avvochu, standard avvochu. Okay, so in the program memory we will have only the main and other called functions. Okay, but the data memory we have stack where the regular type of variables, local variables will be stored, and we'll have global where all the global variables will be stored. Global variables in the sense the variables which we are declaring at the global declaration section. Okay, they will come under the global type of memory. And finally we have the heap thing here, program heap. This heap memory we can assign dynamically. We call this heap as dynamic memory. Dynamic memory antaru. And to play with, to manage this heap, we have our dynamic memory allocation functions. Okay, dynamic memory allocation functions, to play with this heap only we have. So if you want a separate memory from the heap, you have to go for dynamic memory allocation function. Okay, so జనరల్ గా మనం ఏం చేస్తామంటే హీప్ ని మనం మన ప్రోగ్రామ్ లో డైరెక్ట్ గా యాక్సెస్ చేసుకోలేమమ్మా. డూ కీప్ దిస్ థింగ్ ఇన్ యువర్ మైండ్. We cannot access the heap directly into our program. So what we do is we create a pointer into stack. Okay, we create a pointer into stack here, something like this. We create a pointer into stack and we create a memory chunk from this memory pool, from the heap, whatever memory we need. Now we create the memory chunk in the program heap and we try to have a reference into this pointer. ఈ పాయింటర్ లో ఆ రెఫరెన్స్ స్టోర్ చేస్తాం. సో దిస్ ఈస్ హౌ వి మేనేజ్ ది హీప్ ఫ్రమ్ ది స్టాక్, బికాస్ వీ కెన్ యాక్సెస్ ఓన్లీ స్టాక్. వీ కెనాట్ యాక్సెస్ హీప్ డైరెక్ట్లీ హీప్ లోకి వెళ్ళి ఒక వేరియబుల్ ని క్రియేట్ చేయడం, డైరెక్ట్లీ హీప్ లో ఒక ఐటమ్ ని స్టోర్ చేయడం, ఇట్ ఈస్ నాట్ పాసిబుల్. So reference we will create inside the stack and chunk, memory chunk we create in the heap, and our reference pointer will act as a address holder. A pointer will act as a address holder from stack to heap. What we have access to this pointer, and through this pointer we access this heap. Likewise, you remember, ma. Okay, hopefully this concept is clear for you. Okay, and to manipulate this memory, heap memory, we have four different types of functions. They are, yeah, here you can see static memory allocation means what? Static memory allocation requires that the declaration and definition of the program fully specified in the source code. Declaration ante identifier ఇవ్వాలి, and definition ante type కూడా మనం స్పెసిఫై చేయాలి, ఫుల్లీ స్పెసిఫై చేయాలి మన ప్రోగ్రామ్ లోనే, source program లోనే. Okay, the number of bytes received can't be changed at the runtime. So how many bytes this A will take, ma? We know that this A will take 4 bytes at any time. Okay, during the compilation only, statically assigned. So during the compilation only this A will take 4 bytes, and that 4 bytes we can't change at any time. Okay, throughout the life cycle of your program, throughout the lifetime of your program, this A variable, as it is statically defined, this A variable will hold 4 bytes, and that we can't be changed during runtime. Runtime lo aa 4 bytes ni manam change cheyadaniki radu. And whatever technique we used so far for creating variables is this type of technique only, static memory allocation only, that I am explaining over here. So far we used this technique for reserving memory for our variables, arrays and pointers. Okay, static memory allocation only use chesam. Now what is dynamic memory allocation? Dynamic memory allocation uses a predefined function to allocate, for allocating, for deallocating, for reallocating, we are going to use predefined functions, and those predefined functions are nothing but our memory allocation, dynamic memory allocation functions. Okay, to allocate, to release the data. Okay, while the program is under execution, see, while the program is running, we are not defining it statically. We are not doing the memory allocation statically. Statically ante compilation appudu. But how we are doing the allocation? Dynamically we are doing at the time of execution of program. Okay, so that is the beauty of this dynamic memory allocation, or that is how we play with this heap. Okay, unlike static memory allocation, dynamic memory allocation have no identifier associated. I told you na, direct ga manam oka identifier ni heap lo place cheyadam impossible. We cannot create the memory reference directly into the heap. So how we do? It can be accessed only through the address. Okay, it can be accessed only through the address. Okay, and address నుంచి యాక్సెస్ చేయొచ్చు కాబట్టి మనం ఏం చేస్తాం, మనకు స్టాక్ కి అయితే మనకు డైరెక్ట్ యాక్సెస్ ఉంటుంది, హీప్ కి డైరెక్ట్ యాక్సెస్ ఉండదు. సో వాట్ వి డూ, ఇన్సైడ్ స్టాక్ వి క్రియేట్ అ పాయింటర్, and in that pointer we store this address. As simple as it is. You can see here we are creating a local variable x, and where this x is going, ma, onto the stack it is going. Onto the stack it is going. We are creating an array of 3 elements, and where this 3 elements array is going, onto the stack it is going. Okay, because it is statically assigned, statically defined, so it will go onto the stack. Both cases, normal variable case, array case, in both cases it is going on to the stack memory. Okay, because stack memory only we can manipulate statically. Okay, now the concept of dynamic memory allocation. As you can see, what I have done ma, I have created an pointer, integer pointer create chesanu. X ikkada create chesanu. This X is nothing but my integer pointer. And to this X, what I am assigning? This malloc I'm using over here. This malloc is a kind of memory, dynamic memory allocation function. About this only we are going to discuss now. Malloc, calloc, realloc, and free. Four different types of memory allocation functions we have that we are going to discuss now. So normal memory allocation, this is how we do using malloc. How we do? So what will happen? Whatever memory, your whatever number of bytes, here we will specify, generally here we will specify the number of bytes that we want. Okay, the size we will specify over here. Okay, as a parameter to this malloc function we specify the size, how many bytes of heap memory you want. So what this will do, it will take that many bytes from the heap. As you can see here, that many bytes from the heap it is taking here, and it is assigning, I mean that is nothing but it is assigning a pointer to it. That is nothing but it is storing whatever address this memory is having now. That address, the first byte of that address, it is storing into this X. X will be in stack and the complete memory will be in heap. Okay, whatever number of bytes you need now, that overall bytes will be on heap and only X will be in the stack. So this is how we play with heap. Heap లో నుంచి మనకు డైనమిక్ గా మెమరీ కావాలంటే this is how we do. For array also same thing. We keep the array reference on the stack and the contiguous memory location. Calloc means contiguous memory location. Likewise we will get. And here we have two types of parameters. For this calloc we need to give two types of parameters. One is the size of each block. The size of each block we need to give. Say suppose 3 means 3 blocks we will get, and individual block size 3 and ichamu, and then number of such blocks how many you need, that also you need to specify. Say suppose if I say 7, I will get 7 such blocks over here, each of 3 bytes size. Okay, likewise. Okay, hopefully you understood. So this is how the static memory allocation will be done and dynamic memory allocation will be done. Static memory ante stack concept ఏ ఉంటుందమ్మా, heap concept ఉండదు. And dynamic memory allocation ante heap to stack concept ఉంటుంది. So this is how we need to understand. ఈ అండర్స్టాండింగ్ చాలమ్మా మీకు, ఇంకా చాలా డీప్ గా ఉంటుంది ఈ కాన్సెప్ట్, బట్ you need only this much. Okay, this much understanding is more than enough for you. Okay, now memory allocation functions, as I said, now we have 4 different types of memory management or memory allocation functions for doing dynamic memory allocation. Okay, 3 of them are malloc, calloc and realloc. Okay, malloc function, malloc is nothing but M stands for memory. Okay, memory allocation. Malloc in the sense memory allocation. ALLOC stands for allocation. Then calloc, C in the sense contiguous, one after the other. C stands for contiguous allocation. And re in the sense reallocation, RE in the sense reallocation. Okay, memory allocation, contiguous memory allocation, reallocation. Like that you remember these 3 functions. And there is one more function, free function there. Okay, free function, where the above 3 functions, malloc, calloc, realloc, they are responsible for allocating the memory. Your free function is responsible for deallocating or freeing up. Okay, your free function is responsible for freeing up the memory or deallocating the memory which was assigned by these 3 functions. Okay, hopefully you understood. And all these 4 functions, your malloc, calloc, realloc and free functions, they are available in stdlib, standard library header file, where these 4 functions are available under stdlib, standard library header file. These 4 functions are available. So block memory allocation or malloc function. Okay, who will do the block memory allocation? A malloc function will do block memory allocation. Block in the sense a single block it will return. Okay, a single block it will return. So the malloc function allocates a block of memory that contains the number of bytes specified in its parameter. Okay, only single block of memory ni return chestundi me malloc function. Okay, so the allocated memory is not initialized. So initially the allocated memory will have what? Will have the garbage value, unknown values we are saying. Okay, that is the difference between Kelloc and Malloc. Kelloc law, initially all my blocks will be assigned to 0. All my contiguous memory locations will be assigned to 0. But whereas in Malloc, that thing will not happen. Our assigned block will remain uninitialized. Okay, our assigned block, our assigned memory, block memory will be remained uninitialized unless we do it specifically. Okay, so the syntax for allocating the memory from heap using malloc. Okay, so malloc of int size. Here you can see int size. How many bytes of memory you want, that size you can specify over here, and this malloc will allocate that and will return a generic pointer. Now, void star in the sense what? A generic pointer. Respective to the type of value you need, you want to store, you can typecast that generic pointer. If you want to store integer values, you can typecast it as an integer. If you want to store character, you can typecast with character. Likewise it is. Okay. So if the allocation is successful, okay, maybe there is a possibility. If assume that if your heap is full and you are calling the malloc function, if your heap is full and you are calling malloc function, what will happen? Malloc will fail. Memory allocation will fail. So on successful allocation, it returns the void pointer, generic pointer to the first byte of the allocated memory. Whatever memory it has allocated now, from that allocated memory, the first byte's address will be returned on successful allocation. And on failure, if the memory has not been allocated successfully, that is on unsuccessful allocation, it will return a null pointer. Do remember, సక్సెస్ఫుల్ గా అలోకేట్ అయిందంటేనే మనకు ఫస్ట్ బైట్ అడ్రస్ వస్తుంది. సక్సెస్ఫుల్ గా అలోకేట్ అవ్వలేదంటే మనకు ఒక నల్ పాయింటర్ వస్తుందమ్మా. ఓకే, డూ అండర్స్టాండ్ దిస్ థింగ్. Void pointer with void pointer will have the address, first byte address, if the memory is allocated successfully, and void pointer will have null if the memory allocation was unsuccessful. If your heap is full or due to any technical reasons, if malloc function failed to allocate the memory, then you will return, then you will get null pointer as a return value. Okay. Yeah, don't give zero size to this malloc function. Okay, zero size must be at least 1 byte we have to give, 1 as size we have to give. Don't give 0. If you give 0, the result is unpredictable. Okay, and if you try to give 0, then there is possibility that your program may crash, you will get some abnormal behavior from your program. Okay, that is what. So avoid giving 0 to the malloc function, just to avoid any confusion or unpredictable response from the program. Okay, hope you understood malloc. So here is a demonstration on malloc function. We have a demonstration over here. Yeah, what we are doing here is, to this malloc function, we are giving some number of blocks, whatever number of blocks we need, that number of block we are giving, and each block we want the size of integer. How much we want? Because we are storing in the heap, now we are storing the what we call integers. So we want n number of integer sized blocks. That is what the meaning of this one. N multiplied with size of integer, in the sense we want n number of blocks, each of which will be the size equivalent to integer. So quickly you can see, we are reading, enter the number of elements you need to heap, sorry, you need from heap. So here what I am saying, elements in the sense the blocks, memory blocks only. Okay, that size I am reading. Say suppose if I enter 5, then what will happen? N will become 5, and here 5 blocks will be created inside the heap. 5 blocks will be created, each block is of size integer. 5 blocks will be created, each block is of size integer, and initially all these blocks will be uninitialized. They will hold some unknown garbage value. Okay, now, yeah, why I have typecasted with int star over here? Because I told you now, malloc will return void pointer, a generic pointer ని రిటర్న్ చేస్తుంది malloc. కానీ నేను స్టోర్ చేయాలనుకున్నది ఇంటీజర్, సో ఐ నీడ్ ఇంటీజర్ పాయింటర్ మా, because I want to store integers, so that's the reason I'm typecasting with integer pointer. So now my ptr will become integer pointer. Okay, it is returning what, a void pointer, but I'm converting it into an integer pointer, typecasting it into an integer pointer, because I'm dealing with integers. As I said, I'm dealing with integers, so I'm typecasting with integer pointer. So if you want to store characters, then typecast with character pointer. Float, typecast with float pointer, likewise. Okay, so simply after I got the pointer, I'm checking what this pointer holding, whether it is holding the address of first byte or it is holding null. If it is holding null, means no memory has been allocated from the heap. పాయింటర్ లో మనకు నల్ వచ్చింది అనుకోండి, దాని అర్థం ఏంటి, మనకు ఎలాంటి మెమరీ మెల్లాక్ యూజ్ చేసి ఎలాంటి మెమరీ అలోకేట్ అవ్వలేదు అని అర్థం. ఓకే, సో ఇఫ్ దిస్ ఇస్ ట్రూ, ఐఎమ్ సింప్లీ making a statement that memory not allocated and I'm exiting from the program, because if there is no allocated memory, no point of storing any values, isn't it? So I'm simply exiting from the, I'm printing this message and I'm exiting from the program. Hope you understood this part. And if this is false, pointer null avaledu ante దాని అర్థం ఏంటి, పాయింటర్ లో ఫస్ట్ బైట్ అడ్రస్ ఉంది అని అర్థం, isn't it? Pointer null అవ్వలేదు అంటే పాయింటర్ లో ఫస్ట్ బైట్ అడ్రస్ ఉంది అని అర్థం. సో ఇఫ్ పాయింటర్ is holding the first byte address, that means memory is allocated successfully. Then we go to the else part and we'll print a message that memory successfully allocated using malloc. ఈ మెసేజ్ ప్రింట్ చేస్తాం. And after that, enter percentile d elements into the heap, that is percentile d is nothing but n, బికాజ్ మనం ఎన్ని ఎలిమెంట్స్ కి కావాల్సిన బ్లాక్ సైజ్ ని బ్లాక్స్ ని తీసుకున్నాం, n ఎలిమెంట్స్ కి కావాల్సిన బ్లాక్స్ ని తీసుకున్నాం, ఈచ్ ఆఫ్ ఇంటీజర్ సైజ్. ఓకే, నౌ యూజింగ్ అ లూప్ బై ఫాలోయింగ్ ఇండెక్సింగ్, ఓకే, బికాజ్ ఇట్ ఈస్ సిమిలర్ టు అ array ma, okay, it is similar to an array, so I can process this using indexing. So ptr followed by indexing, I'm reading all elements into my blocks. Okay, ptr of 0 will give you the first block as reference here. So whatever first value I will read, that value goes into the ptr of 0. So this is your ptr of 0, this is your ptr of 1, ptr of 2, ptr of 3, ptr of 4. Or you can use pointer arithmetic also. ఇక్కడ పాయింటర్ అర్థమెటిక్ యూజ్ చేసి కూడా మనం ఈ మెమరీ లొకేషన్స్ లో ఇంటీజర్స్ ని రీడ్ చేయొచ్చు, బికాస్ ఆల్ దీస్ మెమరీ లొకేషన్స్ ఆర్ కంటిజియస్ టు వన్ అనదర్. And how I can store the elements, in the sense each memory location is capable of storing an integer. So if I add integer to the pointer, automatically it will go from first location to the second location. That is how I can do pointer arithmetic, or I can use indexing. Indexing use chesi kuda manam ee items ni access chesukovachu. Pointer arithmetic ante add 1 to the first element, you will go to the second element. Add 2 to the first element, you will go to the third element. Add 3 to the first element, you will go to the fourth element. Likewise, you can access, or simply you can use the indexing. Here we are using indexing only just to avoid more confusion. Okay. So ptr of 0 is nothing but first memory block. ptr of 1 is nothing but second memory block. ptr of 2 is nothing but third memory block. Likewise, ptr of 4 is nothing but lastly fifth memory block. So I'm reading 5 elements and then I'm printing those 5 elements onto the output screen using printf. Here I'm reading, here I'm printing, and after printing, after reading, after printing, because those memory locations are no more required for me, no more useful for me. So what I'm doing, I'm simply freeing up that memory using free function. Free function, I told you now, to free up the memory, I will use free function. So this is how we do that one. Free of ptr will free up the memory. So quickly we go to the free function and we will discuss that one first. See here, releasing memory. Free function, why we use releasing? For releasing purpose, we use free function. When memory locations allocated by malloc, calloc or realloc. So far we discussed malloc only. We need to discuss calloc and realloc also. So when these memory locations are no more required, simply what we do, we freed them. We should free them using free function. Okay, we should free them using free function. So here, as you can see, free function will not return anything, so the return type is void and will take a void pointer. ఓకే, వాయిడ్ పాయింటర్ అంటే ఏ టైప్ ఆఫ్ పాయింటర్ నైనా మీరు పాస్ చేయొచ్చు. ఇంటీజర్ పాయింటర్, క్యారెక్టర్ పాయింటర్, ఫ్లోట్ పాయింటర్, ఆర్ ఎనీ జనరిక్ పాయింటర్ యూ కెన్ పాస్ టు ఫ్రీ అప్ ది memory. Okay, here we are passing the integer pointer only, malloc integer pointer only to free up the memory. Okay ma, I will quickly demonstrate the working of this program ma, and remaining two programs, the remaining two topics, that is kelloc, real lock, we will see in tomorrow's session. Okay, I will just demonstrate this so that you will have some idea on it, on this program. Then we will conclude the today's session. Okay, so what I'll do, I'll start writing my program. Hash include stdio dot h. Then I need to include one more header file because I'm going to use memory allocation functions. And I told you all memory allocation functions are part of stdlib.h, standard library dot h. Then you write your main, okay, and in it you declare some variables I comma n. Initially I am declaring, and then now I also need a void pointer, I guess. Yeah, integer pointer only, int star, because I will typecast my void pointer to integer pointer. Okay, now printf, enter the number of blocks that you need, the number of blocks that you need from heap, because it will be assigned from the heap. Okay, next scanf, read that value percentile d into ampersand n into n. Now assign the memory ma. From the heap you assigned the memory. So how it will be? PTR equals to, because it will return the result that it will return the address, that address I need to store in PTR. So what it is? Malloc of n multiplied with each block. What size we want ma? Size of integer. Size of integer. Okay, so likewise, so I need, yeah, the address which is which the malloc function is returning, it is of generic type. I need to typecast it with integer. Okay, hopefully now what I have to, I need to check whether PTR is null or having address, isn't it? So how I can check ma? Simply, if at all PTR equals to null. If it is equals to null, what we are saying, don't do anything. Simply print a message and exit. Printf uh, memory allocation failed. Memory allocation failed. Okay, or dynamic memory allocation failed, because from heap we are taking now. So dynamic memory allocation failed. Then exit. Here only you exit. Don't proceed any further. Here only you exit. That's it. Then else here what we have to do ma, as memory is allocated successfully, print the message printf memory allocated using malloc successfully. Okay, a smiley you can keep like this, because successful allocation. Then what we have to, we need to read the values into it. Okay, printf enter percentile d values to store in heap. Okay, to store in heap. Go to the end. Here we need to supply how many values ma? N number of values we are reading, so pass that n. Now scanf, no, not scanf, for loop. 5 values we read now. For loop I equals to 0, I must be less than n, I plus plus. Now scanf, read the value, integer type of value, percentile d, comma, ampersand, ptr of indexing I. Go to the end. That's it. Reading is over. Print. For 5 values read chestundama. In single loop it will read 5 values. After that, for I equals to 0, I must be less than n, I plus plus. Now accessing and printing. How we can? Printf. Yeah, here you can put one message. printf values in heap are. Values in heap are. Okay. So here you put percentile d space comma ptr of I. That's it. Go to the end and put the semicolon. Okay. Come out of this else and return 0. That's it. So save it. Program got saved now. Uh, Hopefully you understood only this statement you need to understand specifically, and why we are writing this if else, why we are checking with null, and if it is null, why we are printing this message, and if it is not null, why we are doing all this. You need to understand only that thing is important in this program. Quickly compile it. As you can see, it is successfully compiled, and run it. What it is asking me, it is asking me to enter the number of blocks. Say suppose if I want 5 blocks, what it is saying, memory allocation using malloc successful, enter 5 values to store in heap. Okay, I'll make it more readable now, because in every line I need to make backslash n, otherwise they will come in a single line. Here also I need to put backslash n. Here also I need to put backslash n, and enter values from heap. Here I need to put semicolon. I forgot to put all this, so quickly I kept that one, and now I'm compiling and I'm executing. I said 5, so memory allocated using malloc successfully, enter 5 values to store in heap. So I'm storing 5 4 6 8 7. How many values? 5 values. 5 4 6 8 7. So see, values in heap are, they got stored, and from there we are getting back. Okay, they got stored in the whole heap, and from there only we are getting back same values. So this is how malloc function will allocate the memory dynamically from the heap to the stack. Hopefully this concept is clear, ma. Just refer this video one more time. If possible, I will try to post in tomorrow's morning hours only. So in tomorrow evening's session, we will try to discuss the remaining 2 functions, because the class is going very long. So in tomorrow evening, we will be discussing the remaining 2 functions, that is the kelloc and the realloc. 2 already discussed, ma. Malloc for allocating block sized memory, and free to release the memory we discussed. Okay, here I forgot to free up the memory before return. I need to free up the memory, that is free ptr. This is how we free up, ma. Okay, so save it again, compile it, run it. Okay, సో ఫ్రీ చేయకపోతే ఏమవుతుంది అనే డౌట్ రావచ్చు మీకు. ఇఫ్ వి డోంట్ ఫ్రీ అప్ దట్ మెమరీ, యాజ్ లాంగ్ యాజ్ యువర్ ప్రోగ్రామ్ ఈస్ రన్నింగ్ నా, that memory will be consumed, like it will be like a consumed block. It will be treated like a consumed block. And if you need further allocation in your program, further allocation of memory in your program, there is a possibility that heap may get full. Okay, ఒకసారి హీప్ ఫుల్ అయిందంటే మనకు ఎలాంటి మెమరీ అలోకేట్ అవ్వదు, అండ్ ప్రోగ్రామ్ వచ్చేసి క్రాష్ అవుతుంది. మోర్ మెమరీ అవసరం పడ్డప్పుడు ప్రోగ్రామ్ వచ్చేసి క్రాష్ అవుతుంది. సో టు అవాయిడ్ సచ్ ఎ థింగ్, once the purpose of heap is over, once the purpose of heap is over, try to free up that memory. Okay, immediately try to free up that memory. So same thing, ma, compile cheyandi, execute cheyandi. It will ask you to, because I'm executing this program for a small purpose, with a small purpose. Immediately, even if I'm not doing free up, okay, my program is exiting, isn't it? My program is exiting and my program is terminating. So if free function use చేయకపోయినా కూడా ఆ బ్లాక్స్ వచ్చేసి ఆటోమేటిక్ గా ఫ్రీ అప్ అయిపోతాయి. ఓకే, ఆటోమేటిక్ గా ఆ బ్లాక్స్ వచ్చేసి ఫ్రీ అప్ అయిపోతాయి. బట్ వెన్ యూ రైట్ అ ప్రాజెక్ట్, but when you write a program, real time program, 24/7 execute అవుతూ ఉంటుంది మీ program. Let us assume you are writing a program for ATM machine. ATM machine program ఎలా ఎగ్జిక్యూట్ అవుతుందమ్మా? 24/7 ఆ ప్రోగ్రామ్ రన్ అవుతూనే ఉంటుంది. సో అలాంటి కేసులో మీరు అవసరం లేని హీప్ ని ఫ్రీ చేయలేదనుకోండి, there is a possibility that after some time your heap may run out and your program may crash. Hope you understood, ma. Okay, now 5 values I am entering. 4, hit enter. As you can see, all values they stored in heap and they printed from heap and program exited. Okay, hopefully it is clear. So wait for the tomorrow's session. We'll discuss the further concepts in tomorrow's sessions. Thank you very much.